So we want to think a little bit about significant figures, and I thought it'd be best to do it through some examples. So we'll work 3 problems, or maybe 4, and look at how significant figures are related to our knowledge of what we're measuring. So our first question is written in our paper. How many eggs in 3.75 dozen eggs? Well, this seems relatively simple. We take our 3.75 dozen eggs, 3.75 dozen eggs. We multiply that by 10 eggs per dozen eggs, because that's the definition of a dozen, and we go ahead and multiply. We get out our calculator and we'll say 3.75 times 12, and we get an answer of 45 eggs. So we'll write that down, 45 eggs. And now we ask ourselves, how many significant figures did we have in our original measurement? Well, let's look at our answer here, 45 eggs. Now, what do we mean by 45 eggs? In this case, eggs are countable objects. We either have 45 or we don't. We're not including half eggs or thirds of an egg. Similarly, 12 eggs per dozen is an exact definition. It doesn't mean sometimes it's 11 and sometimes it's 13. It means 12. We would consider 45 eggs and 12 eggs per dozen to be exact numbers with essentially infinite numbers of significant figures. In fact, we might go ahead and write my 12 as 12.0000000, and on and on and on. Well, if 45 is exact and 12 is exact, then it must be the case that my 3.75 is also exact. We can actually see a little more about how this works if we alter the problem a little bit. Let's look at a second problem. How many eggs in 4 dozen eggs? Well, just for practice, we'll write down 4 dozen eggs. We'll multiply that by 12 eggs per dozen, and we'll get 48 eggs. Note, I know that I have 48 eggs just as certainly as I knew before I had 45 eggs. Thus, my 4 dozen eggs should have the same number of significant figures as my previous 3.75 dozen eggs. One last example, just to make sure we're understanding our principle. What if I have 3.66666 dozen eggs? You could continue it out to more 6s if you wanted. Well, 3.66666, 5 6s, dozen times 12 eggs per dozen. We'll go ahead and get our calculator out here. 3.66666 times 12 gives me an answer of 43.9992. 43.49s. Now in this case, I can't have 0.99992 of an egg. I know that I either have 42 or 43 or 44 eggs. And so we will choose the most obvious answer of 44 eggs. So it's interesting that in this case, whether it appears that I have 3 significant figures, 1 significant figure, or many more significant figures, if we're dealing with countable objects, we consider that we have infinite significant figures. Now let's take one last example, and let's ask the question, if on average my peach pies weigh 1.2 kilograms per pie, what's the mass of 3 peach pies? The first question you should be thinking about is, how well do I know 3? well, I'm going to assume that we can tell that something's a pi or not. And in this case, we'll treat that as 3 complete pi's with infinite numbers of significant figures. Let's go ahead and do our multiplication now. 3 pi's times 1.2 kilograms per pi. My units of pi cancel, and I get 3.6 kilograms of total mass. But now we reach this question, what does it mean that we have 3.6? Well, my measurement of 1.2 kilograms tells me something about what I know. So I know that my pi's weigh somewhere between 1.5 kilograms and 1.25 kilograms. My statement that it has 2 significant figures means I don't know anything below my 100-gram column. Well, if that's what I know, let's look at what I actually know about the mass. If my pi's really weigh 1.15 kilograms per pi, 3 pi's times 1.15 kilograms per pi. Well, when I multiply that out, I get, it's clear, 3 times 1.15, 3.45 total kilograms. If, on the other hand, they really weigh 1.25 kilograms per pi, well, now we go ahead, do my calculation again, 3 times 1.25, and we get 3.75 kilograms. Which means that my total mass lies somewhere between my lower mass, 3.45, and my upper mass, 3.75. We can see that this value is the same for both my low end and my high end, and you'll note is the same as I got when I chose my average or central mass. My 4 and my 7 lie on either side of the 3.6 I measured here, and so my uncertainty is entirely in this digit. Being a little generous, I say that I have 2 significant figures. That is, both of those values tell me something about my pi. Anything past here is going to change drastically as we change across our range of 1.15 to 1.25. Generally, we'll say for this class that the easiest way to deal with uncertainty is to say that any measurement that has n significant figures cannot yield an answer with any more significant figures than we started with.